Well, this video is for Math 60, and this is for sample test number 1. So this is to help us get ready for that first test. This sample test will have the same types of questions, the same number of questions as the test that we'll take, but different questions, okay? So let's take a look at these. It starts off with a couple of proportion problems. In problem 1, we've got a 40-acre field that yields 600 bushels of wheat. Well, let me just write it down first. And then at the same rate, how many bushels will a 75-acre field yield? And we want to know how many bushels will that one have. So I've got it written down kind of in the same format as a proportion. So if I just put the fraction bars in there and the equal sign, then I've got a nice proportion set up. I've got the acres on the top, I've got the bushels on the bottom. And so to solve for this, we just need to do 600 times 75 divided by 40. And so that comes out to be 1,125 bushels. Okay. And that makes sense. This is almost twice as much, and so this is almost twice as much in terms of the bushels. All right, problem 2. If 3/8 of an inch represents 120 miles on a map, how many miles are represented by 4.75 inches? And I'll kind of write it down the same way. Set it up in a proportion. I've got the inches on the top, the miles on the bottom. And so now I just need to multiply, what is this, 120 times 4.75, and then divide it by 3/8. And that comes out, x turns out to be 1,520 miles. Let's see. And I think that makes sense. Seems reasonable. Okay, and now we've got the percentage problems. So, problem 3 says, Jenny wants to leave a 16% tip. So I'll write that down, 16% tip. For a dinner bill of $74.25. How much should she leave as a tip? And again, there are a number of different ways to set the problem up, to solve the problem. One thing you can do straight ahead is to go $74.25 times 0.16, and that'll give you the amount of the tip. We can also set it up. The bill is the whole. The tip will be the part. The percent is 16. Okay? And so you can do 16 times 74.25 divided by 100, and that'll give you the same thing as if you do $74.25 times 0.16. Let's see, what do we get? $11.88. Okay. Problem 4. Let's see. 1 serving of trail mix contains 67 grams of carbohydrates. Okay, 67 grams of carbohydrates. This is 22% of the recommended daily amount. 22% of the recommended daily amount. So you can kind of see that if you're doing is over of, the word of does appear there, and that's the thing that we're trying to find. Also, you can think of it as 67 grams of carbs is the part that's in the trail mix, right? Whereas the whole is the recommended daily amount. Okay, so we're going to set set this up. 67 over x equals 22 over 100. And let's see what we get here. So 67 times 100 divided by 22. And let's see, I didn't put any rounding on there. When it comes time for the test, again, I work hard to make sure that I put rounding information on there, and if I don't, then that's my problem. And as long as your answer is reasonable, I will mark it correct. So here we've got x equal to 304.5 grams. Okay. Problem 5. Let's see, a flat screen TV is on sale for $550. So, on sale, $550. The TV has been discounted by 20%. Discounted 20%. What was the original price of the TV? So remember how these discount problems work. If you have the original price, then you can find the amount of the discount and subtract it. We don't have the original price. We have the discounted price. Okay? So what we've got to do here is 100 minus 20 is 80%. So this is 80% of the regular price. Okay, so the regular price is the whole, sale price is the part, 80 is the percent, and then we just need to solve, see what that comes out to. Okay, so 550 times 100 divided by 80, $687.50. Okay. Else, problem 6. In a recent poll, 3,500 people were asked a particular question. 1,925 people answered yes. What percent of the total does this represent? So again, here the whole is the 3,500 people who were asked the question. The part are the 1,925 people who said yes, and we're trying to find the percentage. So let's see what we get here. 1925 times 100 divided by 3,500. That is 55%. All right, let's see. Okay, now we've got the unit rate and unit conversion problems. Problem 7, 64 ounces of juice costs $3.84. 64 ounces costs $3.84. How much does 1 ounce cost? Okay, or what is the cost per ounce? Right? That's essentially what this is saying. And so it's saying we want to take $3.84 and we want to divide that by 64. And so that comes out to 6 cents per ounce. If you want to call it that, that's fine too. Okay. All right, let's see here. Problem 8. We've got Jane can run 100 yards in 9.6 seconds. This is kind of a tricky problem, but it is kind of interesting. So Jane runs 100 yards, and I'll I'll double check this. I think it was 9.6 seconds. Yep. Paula runs 100 meters in 10.8 seconds. The question is, who is faster? Okay. And the help that we've got here is 1 meter is 3.28 feet, and 1 yard is equal to 3 feet. Well, you've got a choice here. You can either turn the meters into yards, or you can turn the yards into meters. That's the first step. Okay? Whichever one you do, it doesn't matter, because what we're going to do is we're going to find their speed in, here it'll be meters per second. I mean, the problem with the information that we have is that if we calculated Jane's speed, it would be in yards per second. Paula's speed would be in meters per second, and we can't compare those. So what we can do is, let's change the yards into meters. So first off, 100 yards is equal to 300 feet. And then we'll change the feet into meters. So let's see, 300 feet is X meters. And our conversion says 3.28 feet is equal to 1 meter. Okay, so now we can solve this by doing 300 times 1 and divided by 3.28. 300 times 1 divided by 3.28. So X is equal to about 91.463 meters. So that's how far Jane was running. Okay? So if we take that and divide it by 9.6 seconds, that's saying her speed was 9.53, about 9.53 meters per second. For Paula, all we have to do is divide 100 divided by 10.8. That's 9.26 meters per second. Jane was faster. Okay, that's a little bit trickier than a problem that I would normally put on a test, but I think it is good practice. I think it's a good problem, so that's why I put it on the practice test. Okay, let's see here. Now we get into the integer problems. Number 9, -3 plus -9. It's the same as -3 minus 9, and that's equal to -12. 10. 7 minus 18, relatively straightforward, equals -11. 11. 5 minus -17. So that's the same as 5 plus 17, which is positive 22. 12, -6 minus -12. So that's the same as -6 plus 12, and that's equal to positive 6. Let's see, problem 13. -8. Whoops. -8 times -4, that's positive 32. And again, you can put the plus sign or not put the plus sign for the positive numbers. That doesn't make a difference. Number 14, we've got 16 times -3. That's going to be -48. Got here, problem 15, 21 divided by -7, -3, 16, -56 over -4, should be positive 14, I believe. Okay, let's see here. All right, so that's it for the add, subtract, multiply, and divide with the integers. Problem 17 says express 54 as the product of prime factors. Okay, so 17, we want to take 54 and split it up into prime factors. So there's a bunch of different ways to do this. Number one, 54 is an even number, so it's divisible by 2. So we can do that. Go 2, now do 54 divided by 2, find out 2 times 27. Okay, great. The 2 is prime, so we stop there. The 27 is not prime. 27 is 3 times 9, and then the 9 is 3 times 3. There's our prime factorization for 54. Okay? If you want to, you can write 54 is equal to 2 times 3 times 3 times 3, or 2 times 3 to the third. I don't require that you use the exponents. So what I want to see is your recognition that these are the prime factors. You can put circles around them. You can rewrite it like this. You can rewrite it like this. Those are all correct. So I just wanted to point out, what if you recognize 54 is 6 times 9? That's fine. It just starts the problem a little bit differently, but it ends at exactly the same place. So it doesn't matter how you start. What matters is where you end. Okay. All right. Now let's look at these order of operation problems. Let's see. Okay, problem 18. Got 2 minus 9 squared plus 5 times negative 6. All right, so in this problem, we've got 2 pieces. One here, one here. Here we've got to simplify inside the parentheses first. 2 minus 9 is negative 7. That's going to get squared. Here, you can write this as plus negative 30, because 5 times negative 6 is negative 30. Or you can just go straight to minus 30, however you want to do it. Negative 7 squared, remember, a negative times a negative will give you a positive 49. Minus 30, leave us with positive 19. Okay, let's see. Problem 19. Negative 2 to the third power minus 5 times 1 minus 8. All right, similar to this problem, we've just got 2 pieces here. All right. The negative 2 to the third power is going to be negative 8. Okay? See, if you multiply negative 2 by itself 3 times, a negative times a negative is positive. Positive times a negative will give you back a negative. Okay? Over here, let's work inside the parentheses. 1 minus 8 is negative 7. Now, you've got a choice here. You can think of this as negative 5 times negative 7 is positive 35. Or you can think of this as negative 5 times negative 7, which is negative 35. Either way, we end up with the same thing. Negative 8 and positive 35, and that's going to make positive 27. And again, you can put the plus in front of it or not put the plus in front of it. It doesn't make any difference. All right. Let's look at problem 20. All right. 8 times negative 3 plus 10 minus 22. On the bottom, 4 squared, 2 times 3 minus 5. Okay, on the top we've got 3 pieces. the minus 22, the plus 10, and the 8 times negative 3. The 8 times negative 3 needs to be simplified. And then we can finish off the rest of the numerator there. On the bottom, we've got two pieces, the 4 squared and that expression right there. So let's simplify inside of the parentheses. Let's see here. That'll be negative 2. All right, now let's see here. So the 4 squared is 16. Positive 2 times negative 2 is going to be negative 4. Up on the top, we've got a negative 24, a positive 10, and negative 22. So let's see. That is negative 24 and positive 10 makes negative 14. Minus 22 should be negative 36 on top. Positive 12 on the bottom. And so that should be equal to negative 3. Okay. Let's see what else we've got here. 21, negative 16 plus 7 times 6 on top. Negative 5 squared minus 12 on the bottom. Okay. Let's see what we've got here. So this is going to be negative 16 plus 42 on top. Negative 5 times negative 5 will be positive 25 minus 12. Okay, so on the top, it looks like we're going to end up with 26. And on the bottom, 13. That's equal to 2. Okay, so that's what your test is going to look like. I encourage you to take a look at it before you come to class for our review, so that way you'll have a sense of what's going to be on the test and you can ask any questions that you might have about it. Outside of that, I will see you in class. Thanks.